Hey everyone.
Good morning, guys.
Sorry,
Good morning, guys. Good morning, Billy. And
morning.
welcome to the JConf Peru 2020. And we are with Billy Korando. He's a developer advocate with IBM, has over a decade of experience. Billy is passionate about finding ways to reduce mental capacity waste from tedious work. The top is about JUnit 5. And welcome, Billy. Go ahead. And thank you for your participation.
Absolutely. Thank you. And thank you for inviting me, Jose. And yeah, let's go ahead and get started. As Jose mentioned, my name is Billy Korando. I'm a developer with IBM, a developer advocate with IBM. And in this presentation, we're going to be talking about how we can use JUnit 5 to upgrade our automated test suites. So kind of with that, let's get into it. Oh, I guess one thing before I go too far is feel free to ask any questions in the comments. I'll be regularly monitoring the comments for any questions you might have. So definitely feel free to pop in with any client questions. I'll be more than happy to answer them. So I guess the first thing I want to kind of touch on is why write automated tests? Because it does take a considerable amount of time and effort to write a quality automated test suite and to also maintain it going forward. So we need to understand why justify this time and effort into doing this. So modern development requires speed in getting to production. And so when developers push code to a Git repository or any kind of code repository, you want to be able to build that code automatically and push it to production and all this being automated. However, this does not work without having some sort of guarantee or some sort of good feeling within your organizations that this code is being tested and is being validated to the standards that your organization has. And that's primarily built around automated testing. An organization is going to adopt continuous integration, continuous delivery without any sort of, without the underlying foundation of it being built upon with automated tests. A book that I would highly recommend anyone reading is Continuous Delivery by Jez Humble and David Farley. As far as books go that have kind of had an impact on how I view software development, this book kind of really is up at the top. For a long time before I became a developer advocate, I worked with many different organizations, and getting to production was often a very painful and difficult process. And at first it was like, oh, maybe we're not like using the right process, like we're doing waterfall when we should be doing agile, or we're not using the right frameworks, like we were using struts when maybe we should have been using Spring. And while making those changes, to, maybe waterfall to quote unquote agile workflow, and maybe using Spring instead of like other frameworks, of course, other things like MicroProfile and Jakarta EE are good options as well. But they never really made the significant change to how the development process went. And that's because we were relying a lot on manual processes. And so anyways, I would definitely recommend giving this book a read if you haven't already, because I think you'll probably have a really positive influence on how you view software development as well. A big thing being that replacing manual processes with automated process is pretty key. But a couple of the key benefits of automation, beyond just the speed and labor savings, is that you have the process of automating manual processes makes them more auditable. You get to both see how, like your automated tests, you can review your automated tests to say like, oh, how are we actually testing our application? Are also they're repeatable because you actually have to write out the script to be automated. The computer is going to run through that script the same every time, more or less. Whereas with a manual process, humans, we're not going to do the exact same thing the exact same way every time. So you get a lot more repeatability and consistency in your processes when they're automated versus when they're manual. So then the question often is like, all right, so how much automated testing should we shoot for in our applications? And should it be like 60% test coverage, 70, 80, 100%, or something like that? But really, I can't really give a good answer to that, but what it is, or a specific answer, but what it is when you're confident enough to go to production without any sort of manual human intervention, that is when you have a quality enough automated test suite. And that's going to vary between organizations and really often between applications. An application that is just internal and it's not that important, you're not going to probably want to spend a lot of time writing automated tests for that, because if something was a break when it went to quote unquote production, even if it's internal in that case, the cost of that isn't that significant. Whereas if like your payment processing application went to production and it had some sort of bug that, caused things not to be charged or customers to be double charged, well, that would be a huge problem. So it's obviously much more important. The amount of tests you need to write for an application will vary depending upon the criticality of the application and who's using it. So with that, let's start talking about migrating JUnit 5. If maybe what I just covered before was pretty review, that maybe you already are doing continuous integration and continuous delivery, you have a large automated test suite, let's kind of make the case for why you should consider moving to JUnit 5 if maybe you're already using JUnit 3 or JUnit 4. So the minimum requirements for JUnit 5 is you have to be on Java 8. That was really one of the biggest things about JUnit 5 when it was being written, is to upgrade and take advantage of all the changes that came in Java 8, as well as like about the 3 or 4. Java 4 was written on Java 5, and there's a lot of changes that came between Java 5, 6, 7, and 8 in particular, that were being taken advantage of with JUnit 5. Also, you need to use at least Gradle 4.6. I'm personally not a Gradle person, so I haven't really worked too much with Gradle with JUnit 5. And also, you want to at least also be using Surefire and Failsafe, the Maven plugins, 2.22 or later. You can use older versions, but it's a much more difficult configuration process. Really, the general advice I would recommend, particularly when it comes to build tools, is just to be on the latest version you can possibly be on. That's going to give you the best compatibility and also display the fewest amount of bugs and taking advantage of all the newest features of those build tools as well. So for migration support, I can go through this whole JUnit 5 presentation and maybe there's a bunch of cool features I talk about. But if you already have a large automated test suite that's written in JUnit 3 or 4, you're not going to have to rewrite all of those tests just to take advantage of some of these new features I'm going to talk about. And so luckily, the JUnit 5 team, of course, realized this and has offered excellent backwards compatibility support. So for any test written in JUnit 4, you can just run it just fine in JUnit 5 context. And any test written in JUnit 3.8 or later can also be run in a JUnit 5 context. I think JUnit 3.8 was released like a long time ago. I think JUnit 4 was released like in 2011 or maybe 2008 or something. So really anything, I'm guessing there's probably not many people out there with tests written before JUnit 3.8. There's also support for JUnit 4 or the rule support within JUnit 4, and I'll touch on that as well in a few moments. But like I said, the JUnit 5 team obviously kind of realized the importance of having this backwards compatibility support because there's going to be a lot of existing automated tests out there. And so they made that one of the key points with JUnit 5 is to offer backwards compatibility. And we'll look at that here also in a few moments. Or that backwards compatibility is actually supplied through the org JUnit Vintage engine, which actually just brings in the JUnit 3 and 4 test engines, which is kind of how that excellent backwards compatibility support is provided, just because it's, well, the actual engine that was running before also provided just when running within like a JUnit 5 test suite. And if you want to get the rule support that I was talking about for JUnit 4, you would bring in the package or bring in the dependency, the JUnit Jupyter migration support dependency to get that. And then within a test class that is running, and this will only be running JUnit 4 rules with JUnit 5 test. So like, let's say you want to take advantage of some of the new features I show in JUnit 5, but maybe your organization has written a lot of rules for doing certain things, and you just are taking some time to upgrade them. This is when you would need to do rule support. If you're running just data or just plain old JUnit 4 test, you wouldn't need to do this. But all the same, if you were wanting to run some JUnit 4 rules with JUnit 5 test, you would need to annotate that test class with enable rule migration support, and then those JUnit 4 rules can run just like they did before. Also, there's a bunch of other libraries that people use when running JUnit test. So some of them would be like AssertJ and Handcrest for kind of their more rich and fluid assertions. And any version of those frameworks or those libraries would work with JUnit 4 or JUnit 5. Of course, you probably still want to use more recent versions, but really all the JUnit framework is actually looking for is assertion, the assertion exception, and that's what every version of these libraries would be throwing whenever an assertion fails. So even old versions of these would actually work with JUnit 5. There's also Mockito, and you would want to be a more recent version of this. They've added a lot of new features that integrate well with JUnit 5, but all the same, it's supported within JUnit 5. Test containers, another great library. If you're not familiar with it, it's becoming much more popular, but it allows for integration tests to be run with JUnit more reliably because it can spin up and spin down a Docker container within the life cycle of your JUnit test, which can be great for if you want to connect to a database. Instead of having to connect to a live database, you can just have the test containers spin up a containerized version of that database and then test to make sure things work then. So that way you don't run into issues of like that database being down when running your test. And there's also many other libraries that have been updated or are otherwise compatible to run with JUnit 5. So what are some of the changes from particularly JUnit 4, which I'm guessing is what many people are transitioning from, to JUnit 5? So if you wanted to write a JUnit 5 test instead of a JUnit 4 one, you would use the or JUnit Jupyter API test annotation instead of the one under or JUnit test. That would mark it as a JUnit 5 test instead of a JUnit 4 test. And same with assertions. They've added some new assertions, and those are all located under the or JUnit Jupyter API assertions package. Ignore has been replaced with disabled, and we'll see how it's not just a name change, but there's actually functionality change there as well. Run with rule and class rule has been rolled into this new extensions model, and it's just much more consistent in behavior and in API. And then before class and before, and after class and after have respectively been replaced by before all, before each, and after all and after each. In this case, the functionality is identical as before, but the intent in what they're doing is just much more clear with before all and before each than it was with before class and before, which wasn't always super clear. Like, for example, one before is that before each test or before all classes. And you can see it was like before is before each test, though. Just a bit more clear in their intent. Okay, so let's look at some of the ways the testing experience is improved with JUnit 5. So there's the new assert all, there's exception handling, there's the extensions model, as I mentioned, there's parameterized test, repeated test, dependency injection, and the conditional enabling, disabling. Let's take a look at each of these. So sometimes there's going to be cases where we're going to have multiple assertions within a single test, and a frustrating experience that almost every developer is running into, especially if you have, again, some tests that have multiple assertions with them, is the test starts to fail, you go and fix the first assertion, and then you run it again, and the next assertion fails, and the next assertion fails, and it's kind of annoying when that happens, that you kind of have to run through that test multiple times to fix all those assertions. So to address that, there's now the assert all assertion, and you can see here, you just can wrap that around each of the assertions, and then if we were to run this test again, sorry, I guess I don't actually have an example of this, but if we had to run this test again, instead of just the first assertion failing, all the assertions would fail together and would be reported within the same test report. So that way you don't have to, again, go into that cycle of fixing one assertion, running the test again and fixing the next assertion, and so on. There's also an improvement when it comes to how we handle test exception handling. So in JUnit 4, how you would have generally approached this is by test and then having an expected and then the type of exception up here within the annotation. And then down here is where you would have the test that would then throw an assertion or throw an exception. So one annoying thing, though, could be where you would maybe also have that exception, but then like maybe in this case, I was wanting to check the message to make sure it's what I'm expecting it to be. You would have to have like a try to catch, then assert the exception, and then rethrow the exception, and that would look pretty messy. You would also have the issue of you would have some of the kind of like checking logic of the test case, both within the test case itself, but then also in this declaration. So now we have the assert throws, and you say what kind of exception class you're expecting, and then it'll return that exception, and then you can also then do further asserting against that exception as well, again, like we see here in this case, which overall makes this look much cleaner. I don't have to have a try catch within here, and it also keeps all the logic of the test case within the actual test case itself. So that's kind of a good improvement. You can also declare multiple extensions within a class. So in JUnit 4, you could only have a single run with extension running within a class. And that could be kind of annoying. There have been plenty of times where I was writing some tests against like a Spring Boot application where I would want to do like the Spring Boot runner extension, but then also maybe like the Spring Data runner extension. And I couldn't do that. You would have to do some weird workaround and bunch of setup and whatever configuration work to get that test to work. But now you can just put as many extensions as you want within a declaration of a class, and they would all work just fine together. You can also register extensions programmatically. So this is kind of replacing some of the rule and class rule behavior. So you can now just do register extension. Oh, actually, one last note. The order in which you physically declare these declarative extensions like this within a test file is the order that they would execute. So Spring JUnit config would execute before this data JPA test extension. So there's something to keep in mind that if you do have a specific ordering you want with these extensions, the physical location they are within the code file is the order that they will be executed in. So back to the register extensions, this, again, is kind of replacing the rule and class rule behavior. And programmatically registering an extension, you can have reference like fields within a class and stuff like, and that kind of behavior. So it can have a more of a dynamic nature to the class or to the extension or stuff that's just also kind of based upon configuration within that class as well. So you can register an extension statically or non-statically. A static extension can have behavior that it takes place before the class instantiation. Now, obviously, if it's not static, then you can't do that because obviously a non-static or an instance field would only be around once the class has been instantiated. So that's one thing to keep in mind. If you do also need a specific ordering for extensions, you can add the @order, and then the order in which they're declared or they're defined is the order that they would be run. Without the order extension, there is a consistent ordering, but it's non-obvious. So I don't know particularly when each of these would run. It would be consistent across runs, but it wouldn't be, again, any sort of obvious, like the order that declared it within the code file. So then we also have a parameterized test. So again, kind of in JUnit 4, you would declare a parameterized test with a runner or at run with on a class file, which meant that you can only have that parameterized test within that class file, which at least I ran into a scenario where there was like I was testing a particular section of code, and there's about like a couple of dozen tests that would fit in within this parameterized test scenario, but then like a couple of tests that wouldn't. And so I had to divide those tests across 2 code files. Well, with JUnit 5, I could actually put them all in the same code file. I could just, have my parameterized test marked for one of the test cases, and then it can also still have just normal tests as well within that same test class. So that's kind of nice. That's kind of the benefits again of being able to have multiple extensions within the same test class that you can do that in JUnit 5. And so here in this example, I'm using a method source, kind of like how you would use in JUnit 4 with parameterized tests. And so I'm passing in like a stream of these data beans, and they're just doing some sort of work. However, there's plenty of ways you can actually pass data into a parameterized test. There's also value source, enum source, CSV source, and if you maybe really supplying a lot of data to a parameterized test, you can even do a CSV file source. And I have some code examples that I'll provide a link to at the end of this presentation where I show in-depth examples of all this, and actually also with that code repository, I have links to a bunch of blog articles I've written on this and other JUnit 5 topics as well. So if you want more in-depth examples of what this is, I provide those. There's also a repeated test. So if there's a test that you just need to have executed n number of times, instead of having to maybe within like a for loop within that test itself, or some crazy, maybe just copy and pasting the test a bunch of times. Now you can do this repeated test, and now this test will run 5 times. In this case, of course, it could be whatever number you want. The JUnit 5 context also adds this repetition info onto the test as a method argument. And this can get you like the current repetition, the total number of repetitions, which could be then useful and important for when running those tests. So on the thing of dependency injection, so this is also seen in area which we just saw a little bit in the previous example, but this is an area that saw significant improvement. So in JUnit 4, you could only do dependency injection at the field level, but now they added support for both doing it at the constructor level and then also at the method level. So here, like I'm passing in the constructor argument for a repo, and in this case, I'm using the class repo, and then of course, in this case, I'm using the local repo that I'm passing in here as a method argument. And so, of course, this can be particularly beneficial. I don't know if I touch on it later. I think I do. But if you're using something like Mockito, they also added support to where you can pass in mocks through the method level. And this can be nice for being able to kind of, within the actual test declaration, kind of declaring what sort of dependencies that test is going to be using. So that way, when you're looking at the overall test report, or overall test classes, you can kind of get an idea of the interaction and relationships between the different parts of your code by saying like, oh, okay, this test class, it's going to be dependent upon like this repository or these service classes a whole bunch. You kind of see that a little bit. So that's kind of one nice benefit again of maybe using the method injection. So also there's conditional test execution. So in JUnit 4 and I believe also in JUnit 3, you would just add like the ignore annotation or in some different way for JUnit 3, and then that test would just always be skipped with every execution, which can be helpful for when you maybe need to skip a test for whatever reason. But oftentimes, you may need to skip a test because perhaps some of your developers work on Linux-based systems, some on Windows-based systems. And if you have some sort of test where like you're looking something up within like a file path, well, then that's obviously going to fail on one of those systems because they have different file pathing. So you could, whereas before you would have to either just tell one of the developers like, hey, this is going to fail, but don't worry, it's just because of file pathing. Now you can just do you can have conditional disabling. In this example, we can do it based upon the type of operating system, but there's also a bunch of other pre-built ways of disabling, for example, by JRE level. There's several different ways that the JUnit team has also provided, but also you can completely extend and create your own custom conditions for when a test should be disabled. So maybe a test needs to be disabled on a Thursday, well, you can write your own disabling condition to say, hey, it's Thursday, skip this test because for whatever reason, this test won't work on Thursday, but we're expecting it not to work on Thursday. So this is completely flexible. There's some pre-built options, like I said, of disabling on operating system or by JRE, but there's other examples as well. So then JUnit 5 also kind of filled in some technological gaps within the JUnit framework. So let's take a look at a few of those. Specifically test ordering and then also parallel tests. So if you wanted to order the execution of your test, there's several different options for doing that, along with writing your own custom way of doing that. Probably the most common way people will be ordering their tests, though, is the declarative way with the order annotation. So at the top of your class, you would add the @test method order, and then you would just say the type of order annotation class the annotation class you're using. And here, we then declare the execution order of these tests. Now, specific with something to keep in mind then is tests that these tests would be executed first and second, as you expect between 1 and 2. And so any test that doesn't have an order declared for it, it's going to be executed somewhere in the middle of int values. And I say that then is because also you can say test at order, and you can set it to like max int, and then that test would be executed at the very last of the test. Or you could do max int -1, max int -2, just because if you have like 2 or 3 or more or n number of tests that you want executed at the end of a test class, you can also do it that way. So tests that have an order, like this, these would be executed first and second. Then these without an order, they'd be executed somewhere in the value that the JUnit framework will provide to them is somewhere in the middle value of ints. It's kind of randomized, though. It's not going to be any sort of guaranteed order. It'll be consistent order, but it just won't be guaranteed in some sort of declaration way. And then you can also then set test the max value if you want them executed at the end of a test class. So there's also alphanumeric, and that's as exactly as the name sounds, tests are executed in order of their alphanumeric value. So this test A would be executed first, test B would execute second, test C third, and so on. So whatever the alphanumeric value, that's the order of the test. There's also random. And so as its name suggests, it would be executed in a random order with every execution order. Now, how this would work, though, is that the JUnit context would create a random seed value and then execute that order based upon that seed value, and it would print out that order in the console. Now, if you pass in that seed value and with the configuration patterns here, the JUnit Jupyter execution order random seed, and you pass that same seed value that was executed, then those random tests would be executed in that same order as what there was with that seed. So where this could be useful is if you think there might be some sort of issue where some tests have a dependency on one another, but you're just not quite that sure about it, you can just toss this random order on it. And then if you're starting to get, I see I got a question. I'll answer that here in a second. If you toss a random test class order on it, then you can maybe see like, oh, okay, these tests are failing now. And then you can also get a consistent ordering with that by putting that random seed in here. So got a question. So what do you recommend? Oh. So, what do you recommend for? Yeah, I mean, it has been my experience in most organizations I've worked at where automated testing wasn't ever like seriously followed. Like you kind of like you mentioned in some of the initial phases of a project, you'd be writing tests, but then kind of later on, people would kind of start ignoring it, and and that's kind of why I would definitely recommend the book Continuous Delivery. Is that it kind of goes in as you kind of read through. It's just like the manual processes that many organizations depend upon is actually the source of a lot of pain when trying to get to production or maintaining applications, just because of their inconsistent nature, their labor-intensive natures, and their need for coordination. It just really slows everything down. And there's also just some things you don't really think about. So a lot of organizations I've worked at would often running on very, very old versions of underlying dependencies. Like, let's say, like the current version of Spring Boot is like Spring Boot 2.3 something. But, probably many organizations I'd be working at would probably still be like on Spring Boot 1.5, or maybe they would be on Spring Boot 2.0. Now, part of the reason why they would be on these older versions is just because they don't know what would happen if they upgraded them. And the part of the reason they want to know what would happen is because they don't have automated tests, and the cost and time and effort to upgrade to a newer version and make sure you're not going to break anything would require doing like a full manual regression testing of your applications. And that's just a lot of time and effort. So most organizations simply wouldn't upgrade. And then a problem with that then is, over time, exploits get found in code. And so you just can't upgrade it to, address those exploits. I don't know if you heard about it, but the Equifax hack in the United States, that actually happened because they were running a really old version of Apache struts. But by the time they actually got exploited, the code had already been patched, but they just simply didn't upgrade it. And I can almost guarantee it's because they were probably relying on a lot of manual processes to update stuff, and they just didn't want to take the time and effort to update it. So that's kind of part of the many cases for why you should consider writing automated tests. And if you're going to write them, I would definitely recommend using JUnit 5 for that. Another area where we've seen some filling in of the functionality gap with JUnit 5 from JUnit 4 and before is with parallel testing. There's a lot of flexibility in how you can configure this. Here we can see some of the configuration values you can supply in your build file. And so obviously here, enabling it is turning on the ability to do parallel testing. The config dynamic factor of 1. So this is going to be the number of threads that tests are going to be run simultaneously will be linked to the number of cores on the system that are executing the test. So in this case, on my Mac here, I have 6 cores. So then I can have 6 tests executing in parallel because I have a dynamic factor of 1. If I did a dynamic factor of 2, that could be 12. And of course, from there, you can also do static to where you always want to have 4 tests executing in parallel, no matter how many cores, how many or how few. You can do that as well. And concurrent is tests can be executed concurrently within the same thread. Whereas if it's the same thread, that means our tests from the same class could be executed across threads. Whereas in the same thread, all the tests within the same test class would be executed only within a single thread. Now, if you needed to configure a test to run a little bit differently from your overall project, you can also just do execution concurrent, or you can just set the execution type at the class declaration level. So if I had same thread for this project, then this test would just be concurrent. And the inverse true for here. So you have some flexibility also at the individual test class level if needed. Now, when running parallel tests, there's going to probably be some cases where you might have an underlying resource where there might be certain kinds of conflicts with it. So here, if you're reading or writing from, or if you're writing to a underlying resource, you can add these access modes to say, okay, we're going to probably be changing the underlying state for this resource. So nothing to be executed at the same time. So the read-write, no other test will be executed at the same time as a read-write test for the same resource. Again, this is just an arbitrary string, but you match the resource underlying it by the same string ID, not the same string value. So read-write, no other tests will be executed at the same time as these tests, and these tests won't be executed at the same time either. Retest, these two tests could be executed in parallel, but not at the same time as this read-write test. Also, there's no execution order guarantee in this. So these retests could be executed before or after these read-write tests, or one read-write test could be executed, then these retests, and then another read-write test. So if you do need some sort of order guarantee, of course, check out the order annotation that I was talking about earlier. The final topic I want to cover is there's also some ways to get really creative with JUnit 5 that just kind of just new things that really weren't available in JUnit 4 and weren't really noticeable functionality gaps. So I want to cover dynamic test and test interfaces. So dynamic tests allow tests to be generated dynamically. You would annotate a test method with @testFactory, and then that method will return a collection, stream, or iterable of what's a dynamic test or dynamic container type. And these would be really great for cross-cutting concerns. Oh, sorry. I thought I had a couple examples of these, but let me actually show the code example of this in action. So here for a dynamic test, here I have @testFactory and the collection dynamic node. So what I have going on is, imagine I have like a RESTful API, and we expand this a little bit. Imagine I have like a RESTful API that's taking in some posts or puts, and I have two types of clients. One type of client, they need JSON, and another type of client, they need to be able to send us XML. So all of our post endpoints need to accept both types of media types. So it can be very easy for developers when running tests to forget to annotate that. And it would actually never really show up in any sort of coverage report if they forgot to also then write a test to test for both JSON and XML. You know, any sort of test on the controller would equally show up the test coverage. So here, let me comment this out. Here, like, well, it's an example of like adding a new annotation endpoint. So here, if I was to run this test, after a few moments, it will run and execute, and we should see, yes, 2 test executions, because right now I only have a single post endpoint. Now, if I was to go back in here and uncomment this post endpoint, notice I only have JSON being accepted as a media type. I rerun that test. If you notice, I made no changes whatsoever to that test case. Now I get 4 tests back, and then one of them failed because I'm not accepting XML. So dynamic tests like this can be really great for cross-cutting concerns. Like I said, here in my example of testing different media types, but it could also be good for like security or things like that. Like I said, cross-cutting concerns, logging could probably also be another good example to make sure like you're logging at every endpoint or something like that. So yeah, definitely these are kind of some of the areas where dynamic tests could be very helpful. What I'm actually specifically doing in here within this test is I'm scanning my my class to see if there's any sort of post mappings, and then from there I define how a test should look to make sure that those post mappings are accepting both media types. I also mentioned that there's like dynamic node and then dynamic container. So dynamic container can provide additional nesting to how these tests would show up in a test report. So if you wanted to say for every different annotate or every different test class to kind of have the proper nesting within it, you can use a dynamic container and configure it that way. Again, I have a article that kind of really covers this specifically. So the last thing I want to cover is test interfaces. And this is another thing that took me a while to fully understand, or maybe understand how it could be helpful. So test interfaces are built off of the ability to write default methods within interfaces that was added in Java 8. And these can be useful for when having to test some sort of pattern, but particularly when maybe this pattern may only be partially implemented. And this can also encourage developers to follow pattern guidelines. So an example I like to use of this, just because a lot of people have familiar with it, and it has a specific pattern to follow, and it's just widely known, is REST. So a RESTful API, you should have API v1 resources, and that should be like the base of that RESTful API, and that should be for getting back all the resources, or for posting and creating a new resource. Now, if you wanted to get a specific resource, or update a specific resource, or delete it, well, it should follow this resources. I'll be sure to do that at the end of this presentation, Jose. Thanks for sharing some book, GitHub recommendations as well. So yeah, at the very end of the test, I linked to that on the last slide. So get, put, and delete, they should follow a structure that looks like this. And if you maybe want to do your search, you could do like search by and then like the string of how you want to execute that search. So this is kind of what a RESTful API, the structure it should follow. So you can write a test interface. And so here, like I write a test interface, and it's for doing how a get should be set up. And then I could say like the type of the resource being returned, and then the type of ID we're probably using. And here are then the methods that, if you're writing a RESTful API, when you're writing the test class for it, these methods should be implemented. But then the actual test that be executed, like here I'm saying, test looking up for an existing resource. And I kind of write how the test should look based upon how a RESTful API should look. All right, sorry, skipped a couple of things. So again, this can be helpful though, is a RESTful API may not necessarily be implementing the full REST spectrum. Like you may not be doing get, post, put, delete options, and all that in every single RESTful API. You may only be implementing some of that. So you can have like a test that implements only certain interface of it. And like, again, this is where this is different from JUnit 4. JUnit 4, you could only do this kind of behavior by extending off like an abstract class. But of course, Java allows only for single inheritance, but you can implement multiple interfaces. So here we can see like, okay, one resources controller, it's implementing like our get resource endpoint, our search endpoint. Another resources controller is just only maybe doing post, and another one may be doing all these behaviors. So I have an example of what this kind of looks like in practice in actual code here, where I have like this test customers controller where I have a few of these different test interfaces, like a delete resources, endpoint, get, push and put and post, and then implementing some of these different behaviors or these different interfaces within this test class. And like I said, it's something that you probably won't need to implement a whole lot, but it could be very useful. Here, like I said, I'm using the example of using REST to kind of show off how to do this. But another area where this could be very useful is perhaps when interacting with a database, where you may have your DAOs or your repos follow, like some of the basic create, read, update patterns. And so maybe you want to write some test interfaces that kind of help developers in writing tests to make sure that they're database interactions are following along a certain pattern that you're kind of expecting within your organization. So yeah, that's mostly this presentation. So if you want to link to the code and slides for this presentation, check out this GitHub link, github.com, Korando. Welcome to JUnit 5 v2. I also put together a quick lab, and if you follow this link, you can sign up for the quick lab overall course material, and they kind of run through it. It would take maybe 15 minutes to go through this or so, but you can kind of actually get some hands-on of what it's like to use JUnit 5, and you're not going to have to install or run anything on your system, so that's kind of nice. So do you have any questions or?
Okay, Billy, great talk.
Hey. Thank you.
I have this question.
Yeah, so I kind of mentioned that a little bit earlier. So obviously I would recommend using JUnit 5. And also would recommend, I kind of touched on some of the libraries earlier about using like Mockito, test containers, and the AssertJ. AssertJ is much better for typically writing assertions than just the base JUnit assertions. And for what it's worth, even the JUnit team kind of generally recommends using some of these assertion frameworks. Mockito, at least whenever it comes to doing any sort of mocking or anything like that, is generally my favorite tool for kind of handling that behavior. It's just, for me, always been very easy to use. And they've also kind of since added some really nice upgrades to functionality that integrate well with JUnit 5. And then test containers is absolutely fantastic for doing any of your integration testing needs. Like I mentioned, you can spin up and tear down Docker containers within the life cycle of your JUnit test. And then kind of also went you a little bit earlier during the presentation of some of the reasons why you should consider writing automated tests. It's just a much better way of handling your overall test frameworks than doing manual testing. So yeah. And also for your other question you asked, Jose, with books, like I said, I would highly recommend Getting Continuous Delivery by Jez Humble and David Farley. It's just a really fantastic book that kind of really makes a case for why automation is significantly better than using manual operations. And it's not just, it's faster. There's a lot of underlying reasons there as well.
Okay, Billy. No more questions. Thank you very much for your support and for your time. I hope to see you again in the next conference. Do you want to give some final words or say goodbye to our audience?
Yeah, just if you have any questions, feel free to reach out to me at Billy Korando on Twitter, or email me, william.korando@ibm.com. And also, like here, I link to my blog, and I kind of go into a lot more depth into a lot of these different topics, which can be particularly helpful when it comes to dynamic tests or the test interfaces, which I kind of realize are pretty difficult concepts to maybe easily convey within a few minutes of these presentations. So definitely maybe check that out as well if you're more interested in learning about those topics. And now, hopefully you can see each other again, maybe this time next year. I would definitely like to go down to Lima, Peru at some point.
Sure, definitely. Okay, Billy. Thank you very much, and see you. Take care.
All right,
bye.
Bye.
Bye, guys. See you.